Hey guys, this video is going to go over the law of sines. Now, you may or may not have learned this in geometry, but this is something that we use for non-right triangles. For right triangles, we can use Pythagorean theorem, we can use SOHCAHTOA. Those are the tools at our disposal. But when we have a non-right triangle, those go out the window, and we're left with the law of sines and the law of cosines, which you'll see in the next video. So the law of sines can be used to find any side or angle measure if we have the following information. Okay, it works when you have angle angle side or angle side angle, and it also works when you have side side angle. Now, we're not talking about congruence or similarity here. We're just talking about the pieces of information that are required in order to use the law of sines. Now, the law of sines itself is what you see in the box. It's really just proportions that are equal. It's just saying that side A divided by sine of its opposite angle is the same as side B divided by sine of its opposite angle. And those are both equal to side C divided by sine of its opposite angle. So it's really just like the ratio of the side length over sine of its opposite angle. Now, typically, we're only going to use two of these. We're not going to have like three things being equal to each other, but this relationship is what we're going to use to solve for missing angles and sides. So let's take a look at that. Okay, so here we're looking for x. I have a side length of 10, and it has an angle of 34 degrees across from it. I also have the angle across from that missing side. So what the law of sines allows me to do is set up an equation that's really just a proportion equation. 10 divided by sine of its opposite angle, which is 34 degrees, should be equal to x, our missing side, divided by sine of its opposite angle. So now we have an equation that we can honestly solve pretty easily here. All I have to do is multiply both sides by sine of 52. And this calculation here is going to give me that missing side length. So in this case, again, make sure you are in degree mode on your calculator since we're working with angle measurements in degrees. And this will give you a side length of 14.1. So the law of sines is pretty easy to use when it comes to finding missing side lengths. So let's look at another one here. Okay, this time I'm looking for x. Okay, here's the problem though. I don't have the angle across from x. I have the angle across from this side that's given to me. And this seems like it's a big problem, but really we can figure out this missing angle pretty easily. I'm sure you all know that triangles, their interior angles sum up to 180 degrees. So if I want to find that third angle, it's as simple as just taking 180 minus 64 minus 45, and that tells me that that angle that's left over has to be 71 degrees. So I'm going to erase this here. We know now that it's really 71 degrees. And now I have all of the information I need to set up my law of sines. We can say that x over sine of 71 is equal to 32 over sine of 64. Okay, so now we can multiply both sides by sine of 71. And then we can do our calculation here. So we find that our angle, or I'm sorry, not our angle, but our side length here is going to be 33.7. So finding the side lengths here is really pretty easy and straightforward. It's not a big calculation. Now that changes when we go to find angles. Okay, there's some more things that we have to consider when we have this type of problem. It's possible to have one solution, two solutions, or no solution at all because we really have an ambiguous case here. Okay, when we're finding angles, we're going to be given two sides and just one angle. So we're not going to always know for sure what that one angle might be because there's two unknown angles left. Okay, and it's possible that, like I said, one, two, or no solutions could exist. So here are some important facts that will kind of help us decide what we have for our particular problem. The first thing you need to know is that the sine function always has a range between -1 and +1. Now, that's going to be important later on because we're going to get some errors in our calculator, and it's going to be because we're trying to take sine of something that is outside of this range, okay? The second important thing is that if the sine function is positive, our angle is going to lie in either quadrant 1 or 2. To find any other possible angle. So when we are testing for the possibility of two solutions, we're going to take the angle that we find and we're going to subtract it from 180 to find the other possible angle that we're going to be testing. Okay, probably one of the most important things is something that you already know, which is that the sum of the angle measures inside of a triangle always adds up to 180 degrees, and you also know that no triangle can have two obtuse angles. Now, the reason for that is because by definition, an obtuse angle is an angle that is greater than 90 degrees. Well, if we have two angles that are greater than 90 degrees, that's already going to exceed the 180 degree limit, and that doesn't even take into consideration a third angle. So all of these things together are going to help us make some conclusions about how many solutions we have. So let's look at an example. Okay, now we don't have a picture. We're going to have to draw it here. So I'm just going to draw a triangle. I'm going to try to make it look like a non-right triangle, which is kind of tricky sometimes because we don't want to make assumptions about the kind of triangle that we have here. Okay, so it looks like I drew a right triangle. But you know what? We'll make do with it here. Okay. So let's just name this ABC. We know that angle A is 50 degrees. Side AB is 4. Side BC is 9. And we're looking for angle C, which I'm going to mark as theta. So let's see what we have here. We have an angle of 50 degrees with a side opposite, and we have angle theta that we're looking for with an opposite side length given. So this is perfect for the law of sine. So we're going to go ahead and set it up here. We have 4 over sine of theta equal to 9 over sine of 50. Now, because sine of theta is in the denominator here, we're going to have to do a little bit of work. The other way that you could do this, which I'm going to actually do, is law of sines, when we're working with side lengths, is easier to write and work with like this. Okay, but because this is really just a proportion, there's no problem with really just flipping these fractions over. We could rewrite this as sine of A over side A equal to sine of B over side B equal to sine of C over side C. So this is what I'm going to use because we're looking for a missing angle. It's going to be easier to have that angle we're looking for up in the numerator, okay? So that's just kind of a side note here. So I'm going to really rewrite what I wrote here so that it's going to be easier to solve for theta. We have sine of theta over 4 equal to sine of 50 over 9. So now I'm going to multiply both sides by 4. And then just like we did with the right angle trig, to find this missing angle, we're going to take inverse sine of both sides. So theta is going to be equal to inverse sine of all this stuff. Okay, so when we make this calculation here, we get theta is equal to 19.9 degrees. Okay, and remember that to find the second possible angle, we would do 180 minus this angle that we just found, which is going to give us 160.1 degrees. So these are the two angles that we have to test. Now, let's think about this. If I have this angle of 160 degrees, that only leaves 19.9 degrees left for the other two angles combined, and we already have an angle of 50 degrees existing inside of our triangle. So already with this 160.1 degree angle and the 50 degree angle that's already there, we're breaking that rule of interior angles only adding to 180 degrees. So we need to eliminate this angle. That's not an actual solution because it's going to make the interior angles exceed 180 degrees. Now, there's nothing wrong with the 19.9. We didn't get any errors in our calculation. It's not an obtuse angle. It's not breaking the rule of interior angles summing up to more than 180. There's plenty of room left for that third angle. So because of that, we have one solution. The only possible solution for that missing angle would be 19.9 degrees. So let's look at another example, something where we have a different outcome. So again, we're going to have to draw our triangle. Okay, so again, I'm going to label this A, B, C. We know angle B is 37 degrees. We know side AB is 47. And we know side AC is 29. And this time we are looking for angle C again. So that's going to be our theta. So we have angles matched up with their opposite sides. So theta is across from 47, 37 is across from 29 here. So again, we're solving for a missing angle. I'm going to use the law of sines with sine of A on top and the side length on the bottom. So when I set this up, I'm going to set it up as sine of theta over its opposite side, which is 47, equal to sine of 37 over its opposite side, which is 29. So now to solve for theta, I can multiply both sides by 47. And then we can do inverse sine of both sides. So now when we go ahead and we make this calculation, we get 77.3. And then our second possible solution comes from doing 180 minus 77.3, which gives us 102.7 degrees. So now we need to check, first of all, are either of these angles going to make us exceed the 180 degree limit for our triangle? So the only angle that we actually know is the 37. Now 37 plus 77.3 is less than 180. 37 plus 102.7 is still less than 180 as well. We didn't get any errors when we were making our calculations. Okay, neither one of these angles force us to have two obtuse angles. So both of these angles are a real possibility. And the reason that we don't know for sure is because we know nothing about angle A and we know nothing about side BC. So there's nothing that can make us lean one way or the other with the information that we have. If we had probably just one more piece of info, we could narrow this down and pick one of these as a solution. But with the information given, we just don't know. So there are two solutions. Okay, let's look at one last problem. Okay, so I'm going to try to draw a better picture this time. Okay, let's see, we've got ABC again. We know that angle A is 114 degrees. We know AB is 34. We know BC is 12. And again, we are looking for angle C. So let's set this up. Okay, we've got theta across from that side length of 34. So sine of theta over 34 is equal to sine of 114 over its opposite side length, which is 12. Okay, so we're going to multiply both sides by 34 now. And then we're going to do inverse sine of that. Now, when you type this in, you're going to get an error in your calculator. So I want you to think about why this might be happening. Now, typically when this happens to me, I type it in again to make sure that I didn't just, mistype something. But in this case, we actually have an error, and it's telling us that it's a domain error, which means that the value that we're trying to do inverse sine of is outside of the range that sine actually works for. If you recall, we said that sine can go between -1 and 2, or I'm sorry, not -1 and 2, -1 and +1. If we calculate just 34 times sine of 34, or I'm sorry, I wrote 34 here. It should really be sine of 114. If we do sine of 34, oh, I'm saying the wrong thing again. If we do 34 times sine of 114 and divide that by 12, this value that we're trying to do inverse sine of, this is approximately 2.6, which is outside the range that sine works with. So here's another way we can think about it. This angle of 114 degrees is across from a side length of 12. The side length of 34 is across from theta. Now, a bigger side length means that its opposite angle would need to be larger. Okay, in this case, 114 is across from a side length of 12, which means that 34, the angle opposite from that side, should be bigger than 114 degrees, which is an issue because that would give us two obtuse angles, which is going to exceed that 180 degree limit. So the reason that we're not getting an angle here, the reason that we're getting an error is because sine doesn't work with that value, and also because there's no possible way that we could have a triangle with these side lengths, with these particular angles across from those side lengths. So this is an example where there is no solution that's going to make this triangle actually a triangle. Okay, it's just not possible. Theta would have to be much bigger in order to, be proportional, and there's just no way it can be a triangle under those conditions. So this is what it looks like, okay? You saw one where there was one solution, two solution, and no solution. All right, guys, I hope you found this video helpful. Please reach out with any questions and concerns, and have a wonderful day.